Hi everybody, at this time I'd like to tell you about Mohr's circle for the plane stresses. In this chapter we basically start with the small infinitesimal one, this kind of element, which is located inside some structural element. Let's assume this axis is x-axis and we have y-axis. Small infinitesimal one, we have sigma x and tau xy, sigma y value we have. And surface area at this point, at this here, is A. This surface A. At the moment, maybe here we consider B. Consider that. Okay. At this state, when we consider about some perspective with theta angle rotated. Okay, we have new axis. We have new axis x1 here and y1. The original element was rotated in with theta angle, counterclockwise direction. If it is changed in this way, then our question is what's the value related to sigma and tau value. By applying the formula which was derived in the textbook, we can calculate new values related to sigma x1 and sigma y1 and tau x1 y1. That's also available, but it's a bit complicated. But when you apply Mohr's circle concept, then we can easily find the new values related to rotation with angle theta. Okay, the basic concept is like this one. Here we think about sigma and tau xy, and this direction is positive direction. Okay, especially in the case of tau, this direction is positive. Downward direction is positive. That's one. Why we introduce this kind of one? That's just a agreement, because when we introduce upward direction is positive, then the rotational angle, when you think about positive one and here negative angle is up. Anyway, let's think about the original one. We can introduce some kind of this kind of circle. This one is actually Mohr's circle. Mohr's circle is relationship between sigma and tau xy. Okay, we define this value. Sigma x1 and tau xy is this point. And sigma y and tau xy, minus tau xy is plotted here in minus direction. When you know both points, we can extend we can create the diameter. If we have this diameter, then we can draw a circle. We can draw this kind of circle. Based on diameter. The circle is available. When you plot properly this point and this point, then we can generate so-called Mohr circle. At this point, At this point, sigma x and tau xy. Okay. Now, when you think about theta angle in counterclockwise direction, if it is rotated, then in Mohr circle we consider 2 theta, same direction. Then this place moves to there, and it moves to there, new point. Okay, at this point it is what? Sigma x1 and tau x1 y1. Okay, this distance and this distance. This distance is what? Sigma x1, tau x1, y1. Or when you consider this point, same. If it is rotated there, then this length is what? Sigma y1, and this length is what? Tau x1 y1 minus tau x1 y1. Okay. Next, let's think about some point on the Mohr circle. When you rotate somehow here, then we can go there and there. At this point, sigma x is maximum. At this point, sigma y is minimum. At this point, principal axis exists at this point, and the maximum value happens. And here we can say 2 theta p1, that's principal angle. 2 theta p1. Theta p1 is principal angle, we can say. Okay. Another important thing is we can draw some conclusion. The center point. The center point is what? Center point is sigma average is like this one. That's the characteristic related to Mohr circle. Okay. With this kind of background concept, let's apply an example. Let's move to this example. Okay. We can start with an example like this one. Here, sigma x equals 90 megapascal. Sigma x equals 90 megapascal. Okay. Sigma y equals 20 megapascal. And tau xy equals 0. Tau xy equals 0. Okay, we can draw based on this kind of information. The first one is intuitively. We can draw like this one. This one is sigma and tau xy. Okay, center point. We can find sigma x equals 90 somewhere there. 90 sigma y equals 20 somewhere here, and tau xy we don't have. We have 2 points. Then we can draw a circle like this one. We can easily draw a Mohr circle. Of course, center point is what? Center point sigma average equals 90 sigma x plus sigma y over 2, and 110, then 55. Here 55. Okay. We can draw like this one. You can draw like this one. Okay. Next one. Next one is another case. More intuitively, we can draw more circle like this one. Okay, we can calculate center point is 55.0. That's center point. And radius, we can calculate. Radius squared equals sigma x minus sigma y over 2 squared plus tau xy squared. Okay, when you calculate it, this one, sigma x minus sigma y equals how much? 70, 35 squared. 35 squared. 35 squared. Tau xy equals 0 squared. Then R is what? R is 35. Center point is 55. Here, 55. And radius is 35. Radius is 35. Then 55 minus 35 is 20. Somewhere there, 35 radius. Then we can draw a circle. This one is sigma tau xy. We can also draw with this kind of method. In this case, just calculate center and radius. Then you can draw center point and radius is known. Then you can draw a circle. That's the Mohr circle. Okay. And at this time, when you rotate 30 degree from here, and you rotate about 30 degree in counterclockwise direction, then it can be started from there, and it is this amount of 1. Okay, then if it, we can consider this point is go there, and this point is go there. Okay, if you know 60, 35 cos sine theta, sine 60, then 30.3. That's tau xy. Of course, in this direction is positive. This minus 30.3. And this length is 35. Let's see. Center point is what? Center point is let's say 55 plus, and this distance, that means 35, right? Cosine 60 degree. This one is 0.5, and this one is how much? This one is 17.5, then 72.5. Okay. Total distance is this one plus this one. That's why 72.5. Right. Okay, we can calculate like this one. If we have information about theta degree, then we can calculate this position. 72.5 and 30.3. Okay. That's the way how we use the Mohr circle. When you see final form, if it is rotated 30 degree in counterclockwise direction, then 72.5 direction is different, right? Minus, right? And normal stress is 72.5, and the direction, shear force, shear stress is 30.3 minus megapascal. That's available. Okay, now let's think about another example. Here we have some different kind of unit. And you see on the left side, small element which has sigma x equals 15,000 psi, and sigma y equals 5,000, and tau xy equals what? 4,000 psi, 4,000 psi. Here we would like to know, principal stress. Principal stress and maximum shear stress. We would like to calculate. If it is rotated theta degree, some degree, what's happening? Okay, those things we would like to know. In order to that, the first thing is to calculate, to draw not free body diagram, Mohr's circle first. In order to draw Mohr's circle, first one is to calculate radius, all equals sigma x minus sigma y, 5,000 over 2 squared, plus tau xy, 4,000 squared. Okay, that's the radius. And when you calculate, then this amount, we found radius. Next one, center point to see is sigma average equals sigma x plus sigma y over 2. Sigma x 15K, and sigma y equals 5K, 5,000 over 2. This one is 10,000, 10K. Okay. Let's draw Mohr circle. This direction is sigma, and this direction is tau xy, x1, y1. Anyway, the center point is what? 10,000, 10, somewhere there. This one is 10, let's say. Radius is this amount, 16 something, and radius at this point is what? About 4 there. Then we can draw like this one. Okay, this one is this. You can draw Mohr circle like this one. Okay, the position is like this one. Center point is 10, and sigma x equals 15. This point is about 1, 6, 4. Then sigma x is 15. That's why somewhere there, right? This distance, and tau xy is 4,000. This distance is 4,000. Okay. Then when you draw this way, this point. This point is so-called x, let's say y point. We have some information related to this point. This distance is what? We know how much? Sigma x 15k. Okay. We have radius r. That's why we can calculate this one, this angle. Let's say this angle is this one was theta. Let's say theta to theta. Let's say theta or 2 theta. 2 theta. Let's say theta 2 theta. 2 theta. Let's say 2 theta equals what? We know this value, this distance, the height and radius, and sine, inverse sine, and r, height is tau xy. Tau xy is 4000. Then finally 38 point something degree we can calculate. Okay, 2 theta. And principal stress is here, this one, and this point is what? Center point 10k minus how much? R. This point is sigma y. P. Okay. And maximum shear stress is what? Radius, this distance. What is distance? And this distance is what? Radius. Tau maximum equals what? R. Okay, that's it. Next, when you consider 40 degree rotated in counterclockwise direction, if it is rotated 40 degree, then we consider here 80 degree it should be rotated. Actually, at this point, this angle is 38.66. Then 80 degree we must consider, 2 theta must consider. And 42, maybe it starts, 42 is go there. It goes there like this one. This one is about 42 degree. 41 point here. 41.34 degree. And it is rotated like this one at this point. We know this angle, and then we can calculate this distance. This distance is a value. Because center point we know that, we know the triangle. Then we can calculate this distance. This one is what? R, let's say, it is written in R, cosine 41.34 degree, this distance, and plus center point is 10k. This one is what? New point there. Let's say sigma x1, which is rotated 40 degree counterclockwise direction, rotated. Okay, sigma y1 is minus r cosine 41.34 degree plus 10k, 10,000. Okay. Next, this height, tau x1 y1 equals r sine 41.34 degree. Then this point. Okay. We can find everything. We can find everything related to question. Okay. Let's have a quick review before finishing. We start with this element. Sigma x equals like this one. Sigma y is given like this one. Tau xy. First, the center point. We calculate like this one. This point. Center point is this distance. 10,000. Next, radius we calculated like this one. Then we have radius like this one. Then we can draw this point. Next, we can find the Poisson combination of sigma x and sigma tau x1 y1 tau xy. Sigma x, this location, tau xy 4,000, this point and this point. We can connect this radius. If it is rotated some angle, then we can find this point, this principal stress. When you think about 40 degree, in total 80 degree, you can think of, then it goes there, this point and this point. Finally, we can calculate this position, this distance and height. Then we can solve everything. Okay, let's see in this figure. In this figure, if it is rotated 40 degree, that means 80 degree in Mohr circle, then we have this amount of value is available. In this case, 2 theta was 38.66. 38.66. It's not so good. To change the angle in Mohr circle is 38.66 degree, and half of them is 19.3. This angle. Then we do not have any tau and tau x1 y1. That's why maximum principal stress is given like this one. Okay. And in this case is what? Minus 25.7 degree. Some angle was changed to like this one. You have different kind of combination like this one. Okay. That's for Mohr circle's case. Okay, thank you very much for your attention.